Okay guys, so today we shall look at homogeneous ordinary differential equations. So homogeneous ordinary differential equations is a type of differential equation whereby, just like Bernoulli ordinary differential equations, you use substitution. So like I said, Bernoulli and homogeneous, they are all substitution ordinary differential equations because you substitute, you use substitution method in solving them. So unlike Bernoulli, homogeneous ordinary differential equations, when you substitute, you are going to get a separable ordinary differential equation. Then you solve it as a separable. So what you need to know in homogeneous ordinary differential equations, you need to know these four things. The first thing is this thing, and it's called the standard form. So you need it has to be in a standard form. So you need to have dy dx is equal to this multivariable function, just x and y's, like means you have a function consisting of x's and y's in this side. So this is the standard form. Now, the second thing that you need to know is once it's in the standard form, you need to test whether that equation is a homogeneous. So this is, you have to test. So you can take out a paper and write down these notes. The test here is that where there's x, you put k of x. Where there's y, you just put k of y. If it gives you the same equation after simplifying or evaluating, then it is a homogeneous. But if it doesn't, then it's not a homogeneous. Don't proceed with as a homogeneous, just look for other ways of solving it. So now, let's assume that it's a homogeneous. The third step is to substitute. So this is the substitution part. This is the substitution part. Substitution. So you are going to substitute. Where there's y, you put v of x. You are trying to eliminate y's in the equation. So your equation will have only v's and x's. So since you have dy dx, then you need to find the substitution for dy dx. So you shall differentiate this y. So if I'm going to differentiate it here, if I differentiate dy dx, I'll get what? It will be dv dx is product, then I'll keep x plus, and I'll differentiate x, so it will be dx dx, and I'll keep v. So this gives me 1. So my differentiation will be dv dx x plus v. So now if I differentiate, if I now take this dx to this side, what I'll get is dy is equal to, it will be here, it will be v dx for this part, plus here it will be x, and this will cancel, then it will be dv. So as you can see that this is exactly like that. So you shall take out dx to this side, then where there's dy, you put this one. So we have one example to solve, to demonstrate how we do this. And I have one example as a quiz for you to practice. Okay, so guys, so there's a question here for you. Y prime is equal to y plus x, all that divided by x. So the first thing you have to do is to check if it's in standard form. So give it a guess. And the second thing is you have to test for homogeneity. Is it homogeneous? So I gave you the formula where you can use to test for homogeneity. So let's look at it together. And you see this y prime, you can write it as y as dy dx. So it's equal to, so we said that where there's y, we put kx. So it will be where there's y, you put ky, plus where there's x, you put kx. That's what we said. And all that divided by kx. So let's see if this is going to give me what I started with. So as you can see this one, that I can take out, I can take out k's. So I'll have k here, like that, like this. So, and I can have y plus x, then this is x, and this is dy dx. So from here, you can see that this k can cancel with this one. So this gives you the original. Therefore, this is a homogeneous ordinary differential equations. So, like I said, there's a quiz for you just to test if that equation is homogeneous or not at the end of the video. So, now, since it's homogeneous, let's now solve it. So, to start solving in this one, we said that you use the substitution. So, our substitution was that where there's y, we are going to put vx. So, let's do that. So, you have got let's start with the left-hand side. So dy dx is equal to, where there's y, I'll put vy. Where there's y, I'll put vx plus x divided by x. This is how my substitution will be. Let me write this in red. So that's how my substitution will be. And for the left-hand side, I have to take this to the right first. So it will be dy is equal to vx plus x divided by x, or this multiplied by dx. So if you take this to this side. Now let's proceed. And this dy, we said we are going to substitute with v. It will be this dy, it will be v dx plus x dv, that is equal to vx plus divided by x dx. So this is how my substitution would be like. Now let's start to evaluate this stuff. So I can rewrite this as, this is a common denominator, so this will cancel. It will be v plus 1 dx, because this will cancel and this will be 1. So you can maintain the left hand side, x dv. So like that. So now if you reach this stage, you can see that I can distribute this. So let's distribute. It will be v dx plus x dv is equal to v dx plus dx. So if you distribute this. Now, so from this, I can be able to see which ones are common, and the common ones will cancel, because if they come to the other side, it will be minus. So if I cancel, I can be able to cancel this one and this one. So now you can see what I'm remaining with is x dv dx. So after reaching this stage, you can see that it's now separable, because I can be able to separate the terms. So how am I going to separate them? It will be dv is equal to 1 over x dx. So if this goes to this side, so then I can integrate both sides like that. So if I integrate both sides, I'll have v here, because it's 1, so it will be v is equal to, if I integrate this, it will be ln x plus c. So I have found the solution, but remember our v was what? Our y was equal to vx. So to substitute back this, I'll find v, it will be v is equal to y over x. So I'll take that, put it back. So it will be y over x is equal to plus c. Then I can take this x to this side. Then my answer will be y is equal to 1x times, it will be times, so it will be x plus x c. So this will be my solution for this ordinary differential equation. So the question on the screen, so that question, take it down and try to apply the test for homogeneity and see if it's homogeneous or not, and let me know in the comments below if it is homogeneous or it is not homogeneous. So thank you for watching and see you in the next videos, and goodbye.